Good morning, everyone. This is Murali Krishna Senapati for you today to teach about the graph. So, let us start with the topic. So, what is a graph? If we discuss about the graph is nothing but a collection of nodes and edges. So, when you say the collection of nodes, we know already we have discussed about the linked list, tree, like such thing different type of data structures. In linked list also it is a collection of nodes. In tree is also a collection of nodes, and there are some connecting lines in hierarchical manner. In graph is also a collection of nodes, and there are some connecting lines. So here, how the relationship we can identify, we can say that there is a possibility of random relationship in the graph. So there is no constant for the relationship. In linked list, the connecting will be in serial manner. In tree, the connecting will be in hierarchical manner, top down order, whereas in graph there is no particular condition. So you can have any kind of connection, random connections, random relationship between the nodes. So in a common manner we can say graph is a collection of nodes and edges, where edges are connecting lines, and they are having the random relationships exist between them. So let us go further. So today's the topic of discussion here. What is a graph? What is a graph? What are the different types of graphs we generally observe, like undirected graph, directed graph, and weighted graph? And what are the different graph terminologies generally we are finding at the beginning in the basics, like what is called as adjacency list, what is a vertex? Vertex means nothing but nodes. Edge is nothing but the connecting line. And what are the different type of situation, like self loop, parallel edges, cycles, simple graph, multi graph, what is called as cyclic graph, acyclic graph, connected graph, like that, like pendant vertex, isolated vertex, degree. In there is something called as in degree and out degree. So these all are the different topics we supposed to discuss now. So now let me draw a sample graph. So first of all, what is a graph? If I will say graph, we have discussed that is nothing but a collection of nodes and edges. Sample, for example, if I will say there is a node A and it is connected to B, and B is connected to C is connected to A, and again let us say C is connected to D. Then whatever it is, whatever may be the connection, it is a example of a graph. Okay, so suppose I will take another example, say example 2. Let us say there is node, let us say name I will take as B1, and there is another node, say B2, but then B3 and B4. We are saying, let us say B1 is connecting here, B2 is connecting to B3, B1 also connecting to B3, and V3 is connecting to V4, or whatever it is, vice versa, say V1 is connecting to V4. So this is also another example of a graph. Here these individual locations, these we are calling as nodes, and in graph terminology they are also called as vertices. Okay, so individual it is a node or vertex, whereas a group of nodes are called as vertices. Okay, so we can say graph is a collection of nodes and edges, we can say, or vertices and edges. So here if I will represent this graph in terms of set representation, then we have to identify what are the vertices and what are the edges. So first of all, here next topic I supposed to say, like what are the three different types of graphs normally we find. There are three different types, like called as undirected graph. First one we say it is undirected graph. Undirected graph means the edges does not have any directions. Like these example 1 and 2, they are the example of undirected graph, means the connecting lines does not having any pointing arrow. So means we can say there is a edge, means what, there is a route, there is a connecting line exists from V1 to V2, means V1 to V2 we can go. Similarly, V2 to also V1 we can come back. So this connecting line, this edge does not have any direction. Suppose second type of graph, if I will say, that is called as directed graph. For a directed graph, if I will take the example, okay, say for this only let me modify. For this, if I will represent as a directed graph, I can have a connecting lines. Let us say V1 to V2 there is a connecting line, there is an edge. V2 to V3 there is an edge. V3 to V1 also there is an edge. Say V1 to V4 there is an edge. Let us say V4 to V3 there is an edge. And also let us assume V3 to V2 there is also an edge like this. So now these edges having the pointing arrows, it is specific that which is source and which is destination for that edge. Suppose for this edge, source is V1, destination is V2. V2 to V1 there is no connecting line. V1 to V2 at this point there is a connecting line. You can go from V1 to V2, not from V2 to V1 using this. Okay, so in that kind, if you have the connecting line, then it is called as directed graph. Third one, we call it as weighted graph. Weighted graph means the graph which is having some, where each edge having some weightage. Means, say now these are two examples. Example 1 represents the undirected graph example. Okay. Then example 2 represents the directed graph, right? Now both undirected and directed graph can be represented under third category like weighted graph. How it can be represented? For each edge we can represent some cost or distance or weightage. Let us say now in undirected graph, if I'll say from A to B there is a distance that is 10 kilometer. Let's say B to C there is a distance that is 15 kilometer. A to C there is a distance, let us say 25 kilometer. Okay, so there is a possibility like this distance, let us say C to D there is a distance of 5 kilometer. So whatever may be this distance, this value we can call it in terms like distance. Okay, or we can call it as a cost, or we can call it as a weight. Based on the situation, the graph value can be representing that. Okay, so cost may be a priority value. Suppose you want to move from node A to B or A to C, so this value can be representing some cost, or it may be some weight like that. So sometime if you represent this graph in terms of say from one place to another place we are moving, let us say Bhubaneswar to New Delhi, then if you go by road or if you go by flight or if you go by say train, there may be 3 different possible routes by crossing different individual intermediate places. So during that time the weight may be the distance in terms of kilometer, or maybe the cost amount, ticket amount from one source to another destination, or maybe the time taken to travel from a source to destination. So those values which represents the factor means representing the priority to move from source to destination, to decide to take a decision, that value we call it as a distance or cost or weight. Okay, so now let us move further. What are called as graph terminologies? There are many graph terminologies are there which we supposed to discuss. So first of all, let me discuss about the graph terminology, something called as adjacency list. Okay, adjacency list. So what is an adjacency list? Adjacency list means nothing but it will represent a list which displays about the number of nodes and the connecting edges in terms of a table. Let us say, so for example 1, if I will represent the adjacency list for example 1, so how many number of nodes are? 4 nodes are there. Let me write it is like nodes, okay, then I'll write like adjacent nodes. Adjacent nodes. Now, if I'll represent, first of all, if I'll write the list of nodes A, B, C, D for the example 1, A, B, C and D. For A, which are the adjacent nodes? From A to which are the immediate connected node using single edge, they are the adjacent node. From A to B, there is a connecting line, and A to C, there is a connecting line. So B and C are adjacent. B and C are adjacent. In a directed graph, in a undirected graph, I am finding the adjacency list. Now let us say for node B, which are adjacent again, B to A and B to C. B to A and C. So for node B, adjacent nodes are A and C. For C, the adjacent is A, you can go, B also, D. From C, you can go to A, B and D, all the three nodes. And from D, only adjacent is C. So now this table we can say as adjacency list or adjacency list table. Generally, this table is required whenever you know a particular node, from that node how to move to other nodes by crossing the adjacent nodes. So during that situation, you will be finding the use of adjacency list. Now let me discuss about self loop. What is a self loop? Self loop is nothing but a single edge where source and destination is the same, that is called as self loop. Suppose if I will represent the self loop in this particular graph, let us say I will think of say an edge started from before and it is again coming back to the same place. You can observe this particular edge is unique, which is starting from V4 and it is returning back to the same V4. So for this particular edge, the starting and end vertex is V4 only, it is the same. Then this is called as self loop. This is self loop. Okay. Next one point is cycle. Cycle is like, suppose you are starting from a particular node, maybe by connecting multiple nodes, if you come back to the same place, then it is called as a cycle. So in this graph only you are having some cycles. Let us say V1 to V2 you can come, then V2 to V3 you can come, and V3 again you are coming back to V1. Means by crossing multiple nodes, you are starting from V1, by crossing V2, V3 again you are coming back V1 using these three edges. So this is called as a cycle. So this is a cycle. Similarly, you can observe V2 to V3 you can go, again V3 to V2 also you can come back. So this is also a cycle. Okay, so there are two cycles are there in this particular graph. There is a self loop is there. There are two cycles are there. There is next is something called as parallel edge. Parallel edge here it is, there is no parallel edge. Suppose if I will say there is a connecting line, edge is there. Say here I will draw. So this is a edge which is representing source is V4 and destination is V3. Already there is another edge whose source is V4 and destination V3. So these two edges we can say they are parallel edges. You cannot say these are parallel because here source and destination are different. But here source and destination for both the edges are same and they are started and ended. So they are parallel edges. Now, simple graph. A graph is called simple graph when we doesn't have any parallel edge, no cycles, no self loops like that. So this is an example of a simple graph. Here you will not find any parallel edge. There is no parallel edge. There is no cycle also. Say if you will start from A to B, B to C, again C to A, there is no cycle. There is no self loop. So it is a simple graph. But another graph where if you find anyone, like there is a cycle is there is a self loop, it is present, there is a cycle exists like A to B, B to C and C to A, and there is, you can find there is a parallel edge is also there. Such kind of graph, a graph which may contain any one of these, anything like a simple graph, like a parallel edge, like a cycle, like self loop, then that kind of graph is called as multigraph. Then the graph, sometime it is also called as a cyclic graph. When it is called as cyclic graph, which is very simple, when there is a cycle present, then it is called as a cyclic graph. A to B, B to C, C to A. You can observe there is a cycle exists, then it is a cyclic graph. Now this is also called as a cyclic graph. Why? Because there is a cycle exists. Similarly, next graph you can observe. This is an example of a acyclic graph. Means a graph which does not contain any cycle. Say A to B, B to C, C to A is not there. There is no cycle present in this graph. So it is called as acyclic graph. So you can see the simple graph here also there is no cycle present. At this situation you can also call it as acyclic graph. You can consider there is another example. Now this example you can observe. Say A to B, A to C, there is a two connecting edges. Again B to C, B to D and B to E, there is a connecting edge. Is there any cycle present here? No, right? So it is also called as acyclic graph. You can observe keenly that it is nothing but a tree. So that is why we can call, say, every tree can be called as an acyclic graph. Okay, every tree can be called as an acyclic graph. Next one terminology called as connected graph. You can observe this is an example of a connected graph. What is called as a connected graph? In a connected graph, from each node to every other node, you will find a path. Means you will find some route. There is a way exists. Like suppose A to B you can go, A to C also you can go through B, A to D also you can go, A to B and A to B and then to D. Then A to E also you can go, A to B, B to C, C to E. So A to B, C, D, E, all four nodes you have the path. Similarly, if you say from B to A also you can go through D. B to D you can go, B to C you can go, B to E also you can go. Means B to all other nodes there is a connecting line. Means there is a path exist. C to all other nodes there is a path exist. D to all other nodes there is a path exist. Means from each node to all rest of all other nodes there is path exist. Path means using either one edge or using multiple edges. If you are moving from a source to all other or to a destination, then that is called as a path. So there is a path exists from each node to all other nodes. So it is called as a connected graph. So that is generally possible. You can see, means in a graph, if for every node if you will find minimum one outgoing edge, then definitely there will be a path exist. Okay. And then pendant vertex. Pendant vertex means when you will say that there is a node exists where only one outgoing edge is there and there is no incoming edge present. One pendant vertex means when there is only one incoming edge is there and there is no outgoing edge exists. Means suppose in this particular graph C is a pendant vertex. Why? Because C having only one incoming edge, there is no outgoing edge. E also a pendant vertex. There is only one incoming edge, there is no outgoing edge. D also pendant vertex. C, D, E, these all are three are pendant vertices here. So similarly, for example, I will draw here. Suppose I will take like here one node F for this particular graph, then it is called as a pendant vertex. Next one is called as isolated vertex. Isolated vertex is something like in a graph, if there is a vertex exists which does not have any connecting lines. So you can take any example of this. Suppose I will take this graph. So here I will create a node D. I will say that this graph contains the nodes A, B, C and D. But for this node D, I will not draw any connecting lines. I will not represent any connecting line. But D is a part of this graph. In that instance, D is isolated vertex. Okay, because there is no connecting lines present. Next one is we need to know about degree. Degree of a node or vertex. Degree means the number of connecting lines, okay, of a vertex. How many connecting lines are there? That count is the degree. Suppose here for this particular graph, if you observe properly, so here for node A there are two connecting lines, so its degree is 2. For node B there are three connecting lines, so its degree is 3. For node C, again 3. For node D, 1, 2, 3, 4. So its degree is 4. For node E also 3. For node F, it is 1. So this is the way you can identify the degree. Okay. So these are the degrees. You can understand, I think, the number of connecting lines for each node is called as the degree of that particular node. Now in the degree, again there are two types. What are those degrees? In degree and out degree. In degree means the count of incoming edges, and out degree means the count of outgoing edges. So for node A, in degree means incoming edge is 1, out degree is 1. So let me say 1 in degree and 1 out degree. For node B, 1 incoming edge, there are 2 outgoing edges. So 1 in degree and 2 out degrees. For node C, 2 in degree, 1 out degree. For node D, so 1 outgoing, 1 outgoing, 2 outgoing, 2 incoming, 2 in degree, 2 out degree. For node E, 1 in degree, 2 out degree, 1 in degree, 2 out degree. For node F, 1 in degree, there is no out degree. So you can find the in degree and out degree of A for each node. So just now earlier I said about pendant vertex. So that again I want to redefine it. So I have said that the node, okay, where is only incoming edge, one incoming edge, there is no outgoing edge, I have said they are called as pendant vertex, like C, D, E are the examples of pendant vertex. If you find their in degree and out degree, what is the in degree for node D? 1. Out degree, there is no outgoing edge, 0. For E also 1 and 0. C also 1 and 0. You are getting me? So this is representing in degree and this is representing out degree of that particular node. Incoming edge count is 1. Outgoing edge is not there, so 0. So if you observe for any graph, the nodes whose in degree is 1 and out degree is 0, those nodes are called as pendant vertices. Okay. Thank you very much.